Hi all. So, sorry I've been late to getting to this. I've been pretty busy this past week, and now that some of the AP exams are over, I'm having more time. So, I'm gonna go look through some of the statistics FRQs for you guys who are preparing for the AP statistics exam this week. These were the problems that they put on the YouTube, on the College Board put on their AP YouTube channel. And this is like one of their sort of their practice timed exams that you could go through, and I think they describe some answers, but I was gonna go through it because I had a lot of requests to be like, hey, can you take a look at them and put together a video. So here we go. I'm gonna attempt to type out the answers. I haven't really read through all of the questions, but it when I skimmed it, it seemed like it was more lent itself more to like typing up your answers. And because there's so many issues with uploading files and things like that, I thought maybe if some of you wanted to try typing out your answers, if they're like sort of like short sentences, essay answers, I would go ahead and do that for this one, and I'll give it a shot. But I think if I have to switch to a pen interface, then I might write something down. Okay, so let's start. An online company is hoping to sell a new product by placing a pop-up advertisement on their website. There are two different designs for the advertisement. The company would like to determine which one is more effective, as measured by clicks and purchases. For the first 200 visitors to the updated website, half were randomly assigned to receive advertisement 1 and half to receive advertisement 2. The two-way table summarizes the results. A. Is this an observational study or an experiment? Explain your answer. This is an experiment, and the reason it's an experiment is if you are randomly assigning people, if you are controlling their behavior, and to say like, you're deciding who gets assigned into the two groups, then it is an experiment. An observational study would be just to say like, like people got to self-select the advertisement or something, and you just observe their behavior. Like you are just simply watching, and you are not interacting or controlling any aspect of their decision making in terms of what group they get assigned to. But because of this, you are randomly assigning them. That's an experiment. Okay, so I would say this is an experiment because the online company is randomly assigning the people into separate groups instead of just observing which groups they fall into. So kind of some other examples of experiments versus observational studies, like for example, if you were to compare people who smoke or don't smoke, that's an observational study because you are not allowed to like tell people like you go smoke and you don't go smoke, right? So an experiment would be like these group of people get to smoke, group of people don't get to smoke, right? That would be an experiment. Okay. B, provide one piece of evidence for why advertisement 1 is more effective. Well, let's look at advertisement 1 compared to advertisement 2. More people did not click on advertisement 1, which makes it kind of worse, right? Because the advertisement, you want people to click on it. 8 people clicked and made no purchase, and 22 clicked and made a purchase. So advertisement 1, what did they do better on? Is they clicked and made a purchase, right? More people clicked on advertisement 1 and made a purchase. That's pretty good, right? Because you got 100 total people, 22 clicked, made a purchase. Advertisement 2 clicked and made a purchase. So you had 6 more people who clicked and made a purchase. That makes it better, right? Like from that metric point of view, because ultimately for an advertisement, you want to make sales. Okay, let's look at number 2. Provide one piece of evidence for why advertisement was more effective. Well, advertisement 2 had more overall clicks, right? Because advertisement 2 had 36 people total click versus advertisement 1 had 30 people click. Sometimes for advertisement, it doesn't necessarily mean that the purchase is the most important thing. Just having clicks, just having some people be interested in your product is useful. It makes it a useful advertisement. So more people overall clicked on advertisement 2. Okay, so it depends on how you're looking at it as to which one is better. But yeah. Okay, so let's see. One customer from the study will be selected at random. Are the events of advertisement 1 and made a purchase independent? Justify your answer based on probabilities calculated above. Okay. So what does it mean to be independent? The base rule of independence is, I'm going to write it out, even though it's not going to be part of my answer. Just sort of my explanation is the probability of A given B is equal to the probability of A. Two events are independent is if I condition on B, it doesn't change the probability. That means A and B are independent. Another way, an alternative way to look at this is the probability of A and B equals the probability of A times the probability of B. Okay, that's another way to look at it. But that's because one of the rules is if I take this formula and I multiply both sides by probability of B, probability of A given B times the probability of B equals the probability of A times the probability of B. This is the probability of A and B. That's why, and then that's what this statement is. Both are kind of the same thing. And in your explanation, it kind of just depends on which way is easier to think about it. But this is really the core definition of independence. It means if I condition on the event B, it doesn't affect the probability. It's the same as if you didn't know B occurred or B didn't occur. So in this case, A and B have to be our, the two events, advertisement 1 and made or purchased. So let's look at the probability. The probability of, say, made purchase. The probability that made purchase, given it was advertisement 1. So how do you calculate this probability? This is the way I like to think of it. When you're doing a probability like this, you're saying assuming advertisement 1 is the one that they got picked from. Okay, so let's assume that it's advertisement 1. That means you're assuming just this row right here. Like you're assuming that part is true. So what's the probability that they made a purchase given that is what is happening? Like just the red bar. Well, the probability they made a purchase is 22 made a purchase out of a total of 100, which is 0.22. Ooh, it looks like OneNote's pretty smart. Okay, let's calculate. I have the second part of the question below here. Let's calculate the probability that they just made a purchase. Okay, because if I condition on advertisement 1, and if this is still 0.22, then that would be independent. Probably not going to be. But what's the probability made a purchase? Because I'm not conditioning it, I have to look at the entire set of data, which means I need to look at the total when I'm computing this probability. Okay, this one here. So this is assuming advertisement 1 is true. Or given. And this is, for no condition on advertisement, because it's on which advertisement. Okay, so let's continue our typing. What's that calculation? The probability they made the purchase. Well, how many people made a purchase is 38. Okay, out of 200, and that's equal to 0.19. Because these probabilities are not equal, they are not independent events. Okay? And that's it. That's all you need to do to justify independence there. So that's my text there. Okay. So the online company conducted a test of hypotheses. P1 minus P2 equals 0, and P1 minus P2 not equal to 0. That means the difference in proportions, where P1 is the proportion of customers similar to those in study given advertisement 1 that would click and make a purchase, and P2 is the proportion of customers similar to those in the study given advertisement 2 that would click and make a purchase. The conditions for inference have been met. One of the conditions for inference was met that was that n times PC is greater than or equal to 10 and n times 1 minus PC is greater than or equal to 10, where PC is the combined or pooled proportion. Explain why it's necessary to satisfy this condition. Okay, this has to go to, this is one of the conditions that are necessary when you're doing proportional testing. And that's because if you remember back, it depends on how it was kind of covered to you. But one of the things we do with proportions, proportioner is like a binary outcome. Like each person has a choice here. They're either going to click or they're not going to click. or it's going to be yes or no. That's one of the things about proportions, is the percentage of people who are like in one category versus another category. Okay, the exact distribution of that, when you do n trials, like I sample n people and each person has a binary choice, that's called a binomial distribution. Okay, you have a fixed number of trials, and each trial or sample, and each sample has a proportion or probability that they're going to select one or two of the events. In this case, make a purchase or not make a purchase, or click and make a purchase and click and or not. So the exact distribution is a binomial distribution. But one of the things we like to do, what we do with this is we say, if the sample size is somewhat large enough, then we can approximate the binomial distribution with the normal distribution, because the normal distribution is somewhat simpler to calculate than a complex binomial distribution. How do we decide what is large enough? Is these inference of these conditions here. So these conditions are necessary to approximate a binomial distribution with a normal distribution. That's what those conditions are for. I don't know if they want you to talk about the pooled part. Like, in general, that's what those conditions are for. If they wanted you to talk about, like, why are we pooling them, the reason you use the pooled proportion is because one of the reasons you use a pooled proportion is that when you think the variance of the two distributions are the same. And the variance of a proportion is equal to p times 1 minus p over n. That's what the variance is equal to of a proportion. So what that takes away is that p is the only thing that affects the proportion. And in this case, you're assuming, like, remember, you're always doing your analysis with the null hypothesis. The null hypothesis is your assumption on what you're thinking. Because you're saying that the proportions are different, you're really saying that P1 is equal to P2. If P1 is equal to P2, that implies that the variance is the same. So we're assuming that the variance is the same between the two proportions, because that's what the null hypothesis said. Now, if P1 minus P2 were equal to some number that was not 0, we would not use a pooled, because then we would know that we would be assuming that the variances are different. Okay, so I'm going to add to this a little bit and say that, well, I don't know if they're going to look for that. Like, this is one of those things that I would just add in because they're talking about the pooled. Pooling is necessary because the null hypothesis is assuming the two proportions are the same, which means the two distributions would have the same variance. And we use pooled proportions when the variances are identical, are assumed to be identical. So that's one of the things that we do for pooling, is if we assume that, now some people just like always do it, but like I want you to understand like where that comes from, what assumption we're really making about that. Okay. E. The test result in a p-value of 0.2795. Interpret what this p-value measures in the context of this study. I don't know if you remember when I was talking, there must have been a video, I think the exam tips, but one of the things to say is you should probably have a sheet that has interpretations of every value. What's a standard deviation? What is the p-value? What is alpha? What is significance level? What is confidence level? What is confidence interval? Have a list of all of those things out in terms of wording. P-value, here's the wording you want to use for p-value. P-value is the probability that the observed difference is this large or great, is at least this large given the sample sizes, for the given sample sizes, is 0.2795, assuming the distributions, the population proportions are the same between P1 and P2. So what are we saying here? Is we're saying, remember, the null hypothesis is your default assumption. So all of your calculations of p-value, are assuming that the null hypothesis is true. So that's what the second part of the sentence is saying, assuming the population portions are the same. That's the null hypothesis. So assuming the null hypothesis is true, the p-value is the probability that your samples just happen to be different. Because your samples, if the proportions were exactly the same, just due to randomness in your sampling and just who you get, your samples are never gonna be exactly equal to 0. There's always gonna be a slight difference. So the p-value is to say, like, is that difference just due to chance, or is that difference due to something that our assumption is false? So this is the probability that, assuming that the proportions are the same, the probability that we observed such a large difference from our samples is what the p-value represents. Okay? And the conclusion you do that is, because the probability is 28%, all right? It's 28%. 28% is very likely. It's 1 in 4 chance that you just happen to see a difference this way, okay? And that's very likely. We usually say somewhere around less than 5%. It's less than alpha, but somewhere around less than 5% that we're saying, like, like, it doesn't seem like it's chance. Seems like there's actually a real difference between the two. But because the p-value is pretty large, is fairly large, larger, e.g., I'm going to put an example, e.g. larger than 0.05, the conclusion when the p-value is large is say, like, we don't have enough evidence to say that they're different, because 28% is like pretty common, right? That's there's pretty good odds that it just was coincidence that there was a difference between So just to be clear, the difference we're talking about is this 16 versus 22, right? Like, there's a difference here. And we're trying to decide if that difference is that good? Is that real? Or is it just coincidence? The p-value tells you, like, it's probably just coincidence. Or there's a good chance it's coincidence. It could be that advertisement 1 is better. But from this data, you can't really conclude that it is better, because our probability is just 28%. And it's like, well, that's a pretty good chance that it just happened to be luck. Like, it's maybe they're even in their luck. So we cannot conclude that advertisement 1 is better at we cannot conclude that the two advertisements are different in terms of the proportion of people who would click on the advertisement and make a purchase. The reason I said that, like, not higher and just different is because the alternative was not equal to, as opposed to, like, greater or less than. Now, in our data, we were really seeing that advertisement 1 was higher in terms of a click-made purchase, 22 versus 16. But the test we ran was just if they're different, not if one was greater or not. Okay, so that's why my conclusion is, because the p-value is very large, we cannot conclude the two advertisements are different in terms of proportion of people who would click on the advertisement and make a purchase. You cannot make any conclusion, really. The only conclusion you can say is there's not enough evidence. You cannot say that the proportions are the same. That would be incorrect to state, because you cannot prove something like that. Like, the way you want to think of the two conclusions is kind of like what I explain to my students is, if you are on trial and committing a crime, there's actually two outcomes that are given. You're either proven guilty or not guilty. You are never given innocence. There is a separate process for innocence, but it's important that we say not guilty, because in a court of law, you have to overcome a certain amount of evidence to show that someone is guilty. Otherwise, you assume that they're not guilty. So when a verdict's returned not guilty, that is to say that that person has not been proven to be guilty of a crime. That doesn't mean you've proven he's innocent. That's just saying there's not enough evidence to justify that they're guilty. So similarly like this is how we use the wording in this, is we're really saying that we don't have enough evidence Like the null hypothesis is the not guilty. That's the default verdict if you don't have any evidence. And if the alternative is you need enough evidence to justify whether the alternative is true. And in this case, we don't have enough evidence, so you can't really make a conclusion. The only conclusion you can say is we don't have enough evidence to say that the proportions are different. They could be different. They may not be different, but we don't have enough evidence to conclude that they are different based on this data. Okay, that's very important. You do not want to say that you have evidence to say that they are the same. That would not be correct because because we assume that they're not the same. Like in the calculations, we've already assumed we assumed that they are the same, that they were the same proportion. So that line of reasoning can't prove that. Yeah. Anyway, I hope that helped with that explanation. I know I went a little long on that video, but I kind of wanted to elaborate what I was thinking. I think because I felt like I hadn't been doing enough videos on statistics. So hope you found that helpful, and I will see you in the next one.